Hey guys, it's Mr. Hall again. I'm on a roll tonight. So we're going to do a quick video on multiplying by powers of 10. I don't know if you guys have noticed yet, but 10 is a very special number. It's going to come up in a lot of my videos, but for right now, we're going to talk about how it can have an effect on multiplication. When I say powers of 10, I mean any number that ends with a 10. It could be as simple as 10, it could be 20, or it could be 3,000. Even though we don't necessarily think of that as ending in a group of 10, any number that ends with a 0 is a power of 10. We could break that down into an even group of 10 if we chose to. 240, 10,680, just to give you a few examples of some different powers of 10. Now let's talk about how we can use some strategies to make quick multiplication, to solve multiplication problems quickly. I apologize, I couldn't find the words. If we are multiplying by powers of 10. Let's start with a couple simple numbers. Let's say I have 30 times 3. Okay? So, as I did in my last video, I'm going to continue to do this. So 30, to me, 30 is nothing more than 3 tens. It may seem silly, but to me this is easier to keep up with because all I have to do is remember the number 3 and know that it's not just 3 as in 3 $1 bills or 3 bingo chips like we use in class sometimes as markers. It's 3 groups of 10. I know what a group of 10 is. I know how they're made. We had a video about that. 1 and 9, 2 and 8 makes 10. 3 and 7 makes 10. 4 and 6 makes 10. And 5 and 5 makes 10. I know how a group of 10 is made. And I know that in the number 30, I have 3 of those groups. So, actually, let me change this just a little bit. Instead of 30 times 3, now let's start simple. So here's what I can do. So what this is 3 tens times 3 ones. I won't do quite as much with this, but I just want to let you know these are my thoughts as I work through this problem. So if I did it in the traditional way, in what we would call the standard algorithm. Algorithm is just a fancy word for system or operation. I would have to multiply my bottom factor. Now we're talking about factors. When I do standard multiplication of at least one multi-digit number, I take the digit in my bottom factor and I multiply it by everything in the top. So what I have is 3, and I start in the ones place. 3 ones times 0 ones is 0 because of the the property, the 0 property. Any number times 0 is 0. And after I have multiplied my bottom factor by the ones place in my top factor, I now multiply this same factor by the tens place in my top factor. So now what I have is 3 ones times 3 tens. Well, I know I already have my 0 ones marked, so now I just have 3 times 3. And since I know my multiplication facts, I know that's 9. So 30 times 3 is 9. If we wanted to use some quick addition to check our math, I know that 30 times 3 is the same thing as adding 30 to itself 3 times. Well, 0 plus 0 plus 0 is still 0. 3, 4, 5, 6, 7, 8, 9. So my math is correct. Now, because this is very important, because of the 0 property of multiplication, and again, that property states that any number multiplied by 0 will always result in a product of 0. A billion times 0 is still 0. So what that means, what we can do, I'll leave this up, and I'm even going to draw some arrows. Step 1 was that we multiplied here. Step 2 was that we multiplied here. So let's take 2 different numbers. Let's take 50 times 6. So now, again, I won't write this one out for the sake of space, but I still know that 50 is the same thing. I'm going to think of it as the same way that I thought of this 30 as 3 tens. 50 is nothing more than 5 tens. If it helps you to think about it in money, if someone gave you 5 $10 bills for your birthday, you have $50. So, over here, standard algorithm. Just standard multiplication of a single digit number on the in my bottom factor by a multi-digit number in my top factor. So let's think, if I keep in mind that zero property, if I multiply the 6 by the 0, I know I'm going to get 0. So I'm going to skip that step. And whether it be with my hand, I'm going to cover my 0, sorry if my arm was in the way, or whether it be just in my mind, I'm going to forget about this 0 for the moment. And I'm going to think to myself, what is 6 times 5? Well, 6 times 5 is 30. Okay, and actually I am going to come down here below. So if I said that my 50 is now 5 tens, and I multiply that 5 tens by 6, 5 times 6 is still 30, and now I would just bring down the word tens to think that it's, my product is not simply 30, because 5 ones times 6 ones is worth 30. 5 tens times 6 ones is 30 tens. And the way that I take care of that up here is that after I have done my multiplication, and this part of my product is a result of multiplying 5 times 6, I now go back up and add any additional zeros that are in my problem. So, come here, add an extra 0, and I get 300. Now, this will start to become more useful and will make more sense when we're multiplying 2 multi-digit numbers. So let's do a couple of those before I let you go. Let's take, let's do 60 times 70. So I have 6 tens times 7 tens. All right, again, okay, actually, let's do this one side by side. 60 times 70 again, okay? Under this problem right here, I'm going to use the standard algorithm for solving a 2-digit by 2-digit multiplication problem. And how that works is, to begin, I'm going to start in the ones place of my bottom factor, which is a 0. And I am first going to multiply this 0 in my ones place by the 0 in the ones place here. So 0 times 0 is, of course, 0. And again, I'm still in this 0. I'm not finished with it yet. I have to multiply it by every digit in the top. So now I have 0 times 6, but that is also a 0. Now, if we remember what we learned in class about the standard algorithm of 2 multi-digit numbers, now I'm finished with this 0. So whether it be just mentally in my mind or whether it be with a quick slash through that number, I'm going to mark it out to remind myself that I'm finished with it. What I'm also going to do is put a 0 down here as a placeholder, because this 7 is not just a 7, it's 7 tens. So this 0 pushes me to the tens place that takes care of that for me. So now I take my 7 here and I have to multiply it by every digit in my top factor. 7 times 0 is 0. 7 times 6 is 42. And I add these two numbers. These two numbers here are what we call partial products, because each one is part of the total product. So 0 plus 0, 0 plus 0 again, 2 plus, let's go ahead and call it 0 for lack of a better word, and 4 plus 0 is 4,200. Now let's go over here and let's work that problem again. Except this time what I want to do And again, you can either do this with your hand, or you can do it with your brain. But either way, we're going to forget about those zeros for just a second. And all I need to start with is the simple 1 digit by 1 digit fact of 6 times 7 equals 42. But keeping in mind that my 6 and my 7 are actually both 6 tens and 7 tens, I'm going to bring this part of my answer down here. And just like we did before, I'm going to go back to my problem after I have taken care of the product of my single digit fact. 6 times 7 is 42. I go back up here and I see that I have 1 0, 2 zeros. So in my product, I'm going to add 2 zeros to whatever's already there, and I get the same answer. Only this was much faster. Let's do one more before I let you go. We won't do this again. I just want to show you another one. How we can do this. Now I'm going to switch things up a little bit. Let's do 450 times 30. So, if we were using standard algorithm, the method stays the same even though I added an extra digit. I start here and I multiply the 0 by every digit in this the 0, I'm sorry, let me slow down. I multiply the 0 in my bottom factor by every digit in the top number. So it would be 0 times 0 would come down, 0 times 5 would come down, and 0 times 4 would come down. But instead, my strategy here is to pull out every number, or at least every part of these two factors that are not a 0. So in my top factor, I have the number 45, and in my bottom factor, I have the number 3. So let's slide over to the side. Let's do green just to switch it up. And now I have a more simple problem. It's not as easy as a 1 digit by 1 digit, but it is more simple. I had the more simple problem of 45 times 3, so I want to go ahead and solve that. Well, again, as I've done with every multiplication problem, I'm going to start here and I'm going to say 3 times 5 is 15, or one group of 10 and 5 ones. Now, 3 times 4 is 12, plus my extra group of 10 is 13. So what I have is 13 tens. I put that together, 45 times 3 is 135. So I can bring that answer back under here, 135. Now that I have taken care of all the non-zero parts of these two factors, I'm going to go back and see that I have 1, 2 zeros. So I'm going to add 2 zeros to my product. And I have an answer of 13,500. If you want to run it on a calculator to make sure I'm right, feel free. You guys have a wonderful evening.